Assalamu alaikum wa rahmatullah. In this video, I'm talking about binomial distribution. Before I start some questions on binomial distribution in a probability, I have some assumption to show you what cases what's the meaning of binomial distribution and what is the rule, and then solve some question. Assumption of the binomial distribution. Number one, the experiment involves n identical trials. And n is a whole number, okay? Like when you toss a die many times and flip a coin many times or n times, something like that. Each trial has only two outcomes donated as success or failure. So each outcome or each time you do the experiment, you have only two outcomes. We name the first one success, the other one is failure. And number three, each trial is independent of the previous trial. So it means that the probability, the terms P and Q, the probability of success or failure, the probability of success P and the failure is Q. And it's clear here. I can say the Q is 1 minus P. So the terms P and Q remain constant or still fixed number through the experiment, where P is the probability of getting a success in any one trial, and the P and Q is the probability of getting failure on any one trial. This is a formula used to calculate the binomial distribution. Probability of getting a value x is NCX, P power x and Q power n minus x. NCX, number of ways of selecting x items from n items, and x here is always less than or equal n, okay? And the P, probability of success raised to the power of x, just ask about number of success times the Q, probability of failure multiplied by the number of failure, n minus x, okay? So as you see here, n number of trials or the number of being sampled, x number of successes desired, and P, probability of getting a success in one trial or in each trial, and Q, the probability of getting a failure on one trial or each trial. Let me start by solving question number one. 30% of students in school, so probability here is 0.3. In a student travel to school by bus. From a sample of a 10, the number of trials here 10, or sample size is 10 students here chosen at random. Find the probability that A, only 3 travel by bus, mean 3 students. So I'd like to calculate probability of X is equal to 3. So by applying the rule NCX, probability of success power X, Q power n minus X, you can calculate the n number of trials is 10, C3, times our probability of success 0.3 power 3, probability of failure 0.7, which is 1 minus 0.3 power 10 minus 3 is 7. And to do this by calculator, you will get 0.2668, approximately, something like that. B, less than half travel by bus. Probability of X less than half travel, half number of students. Half 10, X less than half 10, 10 over 2, which is 5. Probability of X less than or equal 5, or less than 5, it means the probability of X less than or equal 4, starting from 4. This means the probability of 4 plus probability of 3 plus blah, 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 until the probability of 0. 0 means no students coming to school or going to school by bus. So you just calculate each single probability and then add, okay? So answer will be like this: 10C0, 0.3 power 0, and 0.7 power 1, plus 10C1, 0.3 power 1, 0.7 power 10 minus 1 is 9, plus 10C2, 0.3 power 2, and 0.7 to the power of 8. Always the sum of these two powers is 10, the same beginning number here for each term. 10C3 0.3 power 3 times 0.7 to the power of 7, and finally 10C4 0.3 power 4 and 0.7 power 6. Calculate this all, you will get about 0.8497, something like that. Okay. Question number 2. A bag contains the counters of which 40% are red. So probability of red, consider this is probability of success, P equals 0.4. And the rest are yellow. This is a failure. This is a Q. And this is a P. A counter is taken from a bag. Its color noted and then replaced. This is performed 8 times. So N here, number of trials is 8 in all. Calculate the probability that exactly 3 will be red. So I'd like to calculate in part A probability of X to be red, to be 3. I want to calculate that being 3 of the counters out of 8 trials to be the red. So the answer is 8C3, 0.4 probability of success here, or being red, power 3, and 0.6, the remaining of 1. You can get this number always by writing 1 minus 0.4, probability, 1 minus probability of success. Power the rest of 3 here, 8 minus 3 is equal to 5. And to calculate this one, you will get 0.2786, something like that, 9, something like that. B. At least 1 will be red. The word at least here means this is the least number, at least 1. The 1 is the least number. It means 1 smaller than or equal, or X bigger than or equal to 1. Okay? Probability of X bigger than or equal to 1 means the probability of X equals 1, maybe 2, 3, 4, 5, 6, 7, and finally 8. 8 here means in the 8 trials, the number of red is 8. So instead of calculating all these values from 1 to 8 expression like this, you can calculate the opposite. 1 minus probability of X is equal to 0. So in the binomial experiment, if the number of tries is 8, the X takes a value start from 0 until 8. So the possible values of X is actually 9 values, N plus 1 values. So here ask you about the sum of probabilities of 8 numbers from 1 to 8. So the only one left, the probability of X to be 0. So just write 1 minus probability of getting 0. So 1 minus probability of X is 0 is 8C0, 0.4 power 0, and 0.6 power 8 minus 0 is 8. Calculate this one, you will get 0.9832. Okay. This is only the trick you can do to solve this question and to save time as well. More than 4 will be red. Probability of X more than 4. X more than 4, it means probability of X to be 5, 6, 7, and 8. Okay? So you will calculate now like this. 8C5, only probability of 5 first, and then 6, and then 7, and then 8. Okay? 8C5, 0.4 power 5, 0.6 power 8 minus 5, 3, plus 8C6, 0.4 power 6, and 0.6 to the power of 2, plus 8C7, 0.4 power 7, and 0.6 to the power of 1, and finally 8C8, 0.4 power 8, and 0.6 to the power of 0, nothing. The sum of these 4 probabilities is 0.1736. Okay? You can check by using calculator. Question number 2. and unbiased die. Unbiased die, the die is a regular cube, has the dots from 1 to 6. Unbiased means probability of each face is 1/6. So probability of success here is 1/6 for each trial. Probability of what? Probability of getting any number of these from 1 to 6, 1 to 3 until 6. Probability of getting 1 is 1/6, of getting 2, 1/6, and getting 6, any number. And biased die is thrown 7 times. So the number of trials here 7 times. The question now, find the probability of throwing at least 5, 6 times. So probability of at least means the x. The x means getting the number 5. Okay. No, sorry, getting the number 6 5 times. So probability of 6 already for each trial is 1/6. Okay. And the same probability of 1 and 2 as I said now. So I want x at least. This word at least means bigger than. X bigger than 5 times. Okay. Probability of x bigger than or equal to 5. So 5, 6, 7, 8. Probability of x equal 5 plus probability of x equal 6 value plus probability of x to be 7. This is maximum because the total number of trials is 7. So in question 3, you can get the 3 values here. The sum is approximately 0.002. You can check your answer by calculating this one. I show you the value. You can write 7c5 and 0 and 1/6 to the power of 5 and 5/6 to the power of 2 plus, I have 3 only, 7c6 and 1/6 power 6 times 5/6 and power of 1 plus 7c7 times 1/6 power 7 and the 5/6 power 0. Okay, calculate this one. I get approximately, you'll get 0.002. No problem. It's a very small probability here. It's rare. Question number 4. A fair coin is tossed 6 times. The probability in the coin, it's a fair. Probability of head is 0.5. And the cube probability of getting other one, tail or failure, is 0.5 as well. The number of trials here is 6. Find the probability of throwing at least 4 heads. So probability of x at least, just write bigger than or equal. So x bigger than or equal 4. Okay. So bigger than or equal 4, it means probability of x may be 4 or 5 or 6. Yeah. So the answer is probability of x to be 4 is 6c4 0.5 power 4, 0.5 power 2 plus 6c5, 0.5 power 5, and 0.5 power 1, because you always subtract 6 minus 5, 1. And plus 6c6, 0.5 power 6 times 0.5 power 0. And calculate this, you will get the value of, I can do something nice. 0.5 here, 0.5 this part, all 0.5 power 6. You can just take it common factor. And still inside 6c4 plus 6c5 plus 6c6. Do this by calculator, you will get 11/32, exactly. Or approximately 0.34, okay? 34375, not exact, not approximately, it's exact value. Okay, next one. Question number 5 and last one for this video. 10% of articles from a certain production line are defective. So probability of success here is defective, no problem. A sample of the sample size here, 25 articles. Find the probability of at most 4 defective items. At most mean this is the most. So the x must be smaller than or equal. When I said at most 4, 4 is the biggest. So the x must be smaller than or equal 4. It means probability of x to be maybe 0, 1, 2, 3, and 4. Okay, and just to start by adding all these probabilities by writing 25C0, 0.1 power 0, and 0.9 power 25. Okay, plus 25C1, 0.1 power 1, and 0.9 power 24, and so on. How many times you write? 1, 2, 3, 4, 5. 5 times. And 25C2, 0.1 power 2, and 0.9 power 25 minus 23, plus 25C3, 0.1 power 3, and 0.9 power 22. Okay, last one. 25C4, 0.1 power 4, and 0.9 power 21. Calculate each probability, 1, 2, 3, 4, 5, okay? And again, the value is about 0.902, something like that. Okay, inshallah, in the next video, I show you how to use the GDC, the Texas Instrument 84, to do all of this in one step. Okay, follow me. I am Muhammad Zidane. Thank you so much. Goodbye.